Seniors. This video is going to be on Packet Tracer 2.7.1. It covers single area OSPF configuration. So let's get into it. So I have 2.7.1 pulled up right here. It gives our network to us. And the first thing it asks us to do is to activate OSPF using network statements and inverse mask on the routers in the headquarters network. So we have our headquarters network over here, and we're going to have to configure OSPF on all three of these devices right here, P2, P1, 2, and 3. So I'll go ahead and get into P2, P1 right here. Enable, get into privilege exec mode, config T, get into global config. And first we have to create the OSPF process. So we're going to hit the router with a router OSPF10, and that creates our OSPF process of 10, and that's why our prompt right there just changed. So now we're going to start those network statements. If we look at the table that was given to us, we are operating in these 10.0.0. something networks all/30. So we know when we're configuring these network statements, we're looking at the inverse of the subnets right here. So the inverse of 255.255.255.252, which is a /30, you're going to get 0.0.0.3. So that's going to be what we're configuring right here. So if we go into P2, P1, let's try to bring that back up. Nope, not reminders. Nope. Oh my God. That's not what we were. Okay. I don't know why it's doing that. It's fine. Okay. Network 10.0.0.0, 0.0.0.3, and we're going to put this in our backbone area. It's not really our backbone area since we're just doing single area OSPF, but that is what that would be. Area 0 would be your backbone area in multi-area OSPF. So we're going to go ahead and get that in there. And just so everybody understands, that is propagating this network right here, this 10.0.0.1/30. We're using the network address, which would be 10.0.0.0 in that statement. That's where we got that .0 from. So we're going to do the same thing for this .9, and then the same thing for the .13. So instead of a .9, we're going to have a .8 in our statement. Instead of a .13, we're going to have a .12. So we'll go back into P2, P1 here and just do the same statements. All right. And then we have to do the same thing for the other routers, but the statements are not going to be the exact same because they are advertising the links that are respective to what they're connected to. So P2P up here had the 10.xxx links all connected to it, but we see down here we have some local LANs connected, so these statements are going to be a little bit different. So if we go into P2P2, share some of those networks. So we're going to start with a router OSPF10 command to create the instance. And it shares the .0 network with the other router, so we can go and put that in there. And let's see. And we can see right there, we just formed a neighbor relationship. That's what you're seeing in the CLI right there. So we have 1.0 and 2.0 connected, and we also have this 10.0.0.4 connected, so we're going to need 3 more statements. Like you just saw with me pointing out right there, the packet tracer does kind of give it to you with the network commands you need, but like I was showing earlier how you can deduce it from what was given to you in the table. That's not how you spell network. And we're using different wildcard masks right here because we're looking at /24 networks on those LANs. So that's why we don't have a .3, we have a .255, because the inverse of a /24 would be a .255 ending. So those gives us our networks for the second router. And we'll go ahead and hop into the last one. And on this last one is where you'll really see the neighbor adjacencies forming between the routers. So same process right here. Use that same process ID. Helps if I go into global config. And let's see what networks we're looking at. So we have a .8, a .4, and the local LAN in this case is 3.0, but we have a /28, so the inverse of that. So that leaves us, if we're looking at it from a subnet perspective, we have a 255.255.255 /30. The inverse is .15. That's what we're looking for. I'm having a brain fart, but that's what we're looking for. So we'll go ahead and get in here with the network statements. And then this will give us a neighbor adjacency right here after I enter it. I lied. Oh, no, there it is. Okay. This should also give us a neighbor adjacency after we enter it. And again, that's because this is not, these are the networks that are not connected to the LANs, they're connected to another router, so the adjacency is being formed between those routers. Let's go to a second, we'll see if we can get that network message out of it. There we go. And we're gonna go ahead and do a statement for the LAN right now. I may not mistype, that would be tragic. NetWalk, yeah, there we go. We're in China now. Okay, let's go and look at our next steps. Activate OSPF by configuring the interfaces of the network devices in the data service network where required. Okay, so what it's saying right here is we have to go onto these interfaces and actually propagate OSPF, because we can configure it with network statements, or we can also just activate it on the interface. So we're going to go ahead and go over here to BC1 on the in the data services network. And in case anybody's confused where I'm getting that interface from, we're just doing it on the interfaces that are connected. So we can just hover over right here if it wants to. And we can see what interfaces are connected. So we saw it is flash G000 right there, so that's where we're getting this from. And then we're going to want to do the same thing for BC2 and BC3. And we just had a neighbor adjacency form because we had a network statement over here, and then we configured on the interface over here. So if we go to BC2, we're going to activate on the interfaces. Probably going to be looking at a G00 and a G001. If it wants to get, yep, okay. Then lastly, we're going to need to do it for BC3, so let's just validate our interfaces real quick over there. Probably the same. Yep, okay. Awesome. Okay. So now we need to configure these router IDs, and that's just going to be with our router ID command, and it tells us exactly what routers to configure this on. So once BC1 tab 6.6.6.6, so we'll go ahead and go in here, we'll exit out of this, go into our OSPF process, which is 10, and go ahead and give it that router ID command, and it wants 6.6.6.6. That is all set for that router. And then we're going to come over here to BC2, which it wants 5.5.5.5. And remember, these router IDs can be manually configured. If they're not manually configured, it's going to look for the highest loopback address. And if that's not configured, we're going to be looking at the highest physical address. And I think we want 4.4.4 for this last one. As you guys can see in the CLI, we're just getting some logs with the neighbor relationships forming. So that's all set for that step. Configure OSPF so that routing updates are not sent into networks where they are not required. So that's our passive interface command. And where do we not want these updates sent? We do not want them sent to local LANs. So all these interfaces right here that are connected to LANs and not to another router, we're going to want to silence those guys. So we'll start over here with P2P2. And we are still in our OSPF10 instance, so we can go ahead and do the passive interface commands right here and quiet down these guys so they don't send updates out. Because if we send, the reason we're doing this is, it's a security thing. If we don't want to send these OSPF updates that tell everybody what's going on in the network, how it's laid out, to interfaces that don't need them. And obviously a LAN where a router does not need that. So we'll do it for this guy. Then we also have to do it for the BC network. And what we're going to do right here, we don't want to send these updates to the cloud, right? Obviously, we have a switch right here, but we still need to send updates to these other routers, so we aren't going to silence this interface. We're just going to want to silence this interface that's going to the cloud. So let's see what that is for us real quick. That's going to be S011. So we'll go ahead and go in here. And we'll do our passive interface on that. And then for BC2, we are going to want to silence this LAN right here. Then we're going to want to do the same thing on BC3 because it has that one LAN connected right here. All right. Configure router BC1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. So we're going to go over here to BC1, and we should know our highest OSPF interface priority that we can set is 255. So we're going to go over here, go into the interface that is connected to the other routers, exit this real quick. And that sets our priority. So this will become the DR when those guys go to negotiate who the DR is going to be. Configure a default route to the ISP cloud using the X interface command argument. So this is something I believe we went over the last Friday I was in there with you guys, was IP routes, and fully specified versus a recursive static route. So we'll go ahead and we're setting a default static route right here. So we're going to use our quad 0 command. And then our exit interface is that same interface we were using earlier, S011, to get out to that cloud. This is negligible. You'll get this message every time you set a default route. Don't worry about it. Automatically distribute the default route to all routers in the network. So that is our default hyphen information originate command. So we have to do that on the router where we have a static route, and we just simply go back into our instance and we hit it with that default hyphen information originate command, and that's going to make sure every other router is getting that route to get out of the network. Configure the OSPF routers so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. So this goes back to OSPF's cost metric, right? Reference bandwidth over interface bandwidth, and we know the reference bandwidth by default on a Cisco device is going to be 100 megabits per second, and that gets divided by the actual interface bandwidth to see what the cost of that link is going to be. So, for example, obviously OSPF isn't happening on this link right here, but let's just say it was on, a 100 megabit per second link, and we did not change the default cost. So we have a reference bandwidth of 100 megabits and a actual interface bandwidth of 100 megabits. So the cost in a numerical value for that route would be 1. Let's say we had a gigabit link and a reference bandwidth of 100 megabits per second. You can obviously see how we'd get a better cost in that scenario. All right. So we're going to have to go into P2P1 right here. We can start right there. And we're just setting the reference bandwidth. So we have to go back into our OSPF10 instance. That's where, pretty much all of our commands are being issued. And the command to set our bandwidth right here, our reference bandwidth, is auto cost reference bandwidth 1000, because it's asking for the cost to be 10. Configure the OSPF router so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. Right, so we want to set this one to 1000 so that when it's divided by 100, we get 10. Awesome. And we're going to have to do that on all of these routers. And you can see why we're having to do it across all the routers. I didn't mention it when I read it in the last one, but we get a message right there saying that we have to change it on all the routers. Oh, did not mean to do that. see what our next step is. Configure the OSPF cost value of P2P1 interface 00111 to 50. Oh, it said P2P1, not BC1. So we're going to have to go onto that interface because we're configuring a specific interface cost. And we just set the cost to 50. And our last step, we're working with hello and dead timers. This is maybe even the easiest part of the entire thing. In order for them to form a neighbor adjacency, we're going to have identical hello and dead timers for any OSPF routers that want to form an adjacency. So this is having us make sure they can form it right here between P2P1 and BC1. So we're going to go ahead and go in here into P2P1 and set the cost that it wants. We're going to look at a hello interval of 20, like I was saying, and a dead interval of 80. Okay, let's make sure we do everything right. And we got 100% completion. So we configured OSPF by going and doing network statements over here, and we did it by enabling it on the interfaces over here. We formed the neighbor relationships, formed a relationship between these routers that are in these different areas, and this is all one big area, OSPF area 0. This isn't multi-area OSPF. So that's it for this packet tracer. Let me know if you guys have any questions.